4 sine t. And what goes here? Negative
4 cos t.
4 cos t. So far so good? What's this though? Oh, we need the derivatives. Be careful, don't put RT here. Look, R prime of t. Let me get a vector on that. Make sure when I got it right there, I'm looking at my work. Make sure I have it in case I sometimes make that typo on the board. Oh, it's there, it's there. Okay, good. It's good, okay. It's an R prime of t, so what's that derivative?
Negative 4 cosine t.
This is the derivative of this. Negative 4 sine of t.
Sine of t, sorry.
And what's going here? I need you to take the derivative of it. Look, R prime of t. What's the derivative of that?
Cosine.
4 cosine. dt. Then just do the dot product. This has a lot of trig functions, so I'm hoping everyone we're not doing some crazy what. We need trig identities to work this thing out, or power reducing identities. Do you agree? I know that makes a lot more work. We'll see. We'll see. We'll have to pull out any old power reducing item. We'll find out. What's that times that? Negative 4 sine squared t plus. Oh wait, 4 times 4. That should be a what? So I apologize that. That times that is this. Plus, now you gotta multiply these two. That's a dot product, right? This times this, plus this times this. What's that times that?
Negative 16 cosine square t.
And I'm delighted for what I see right now. It looks like we do not need any trig identities in terms of like power reducing identities. We need just one very popular trig identity. Factor out the negative 16, what's in there?
1.
Just a 1. Just a 1. That's the trig identity I like. Sine squared t plus cosine squared t is a 1. Now I do want to point out that if this came out to be like sine squared minus cosine squared, yes, I would have been doing those power reduced identities. I know. But this came out nice, that's a 1. 1 dt. What's that integral in?
Negative 32.
Negative.
32.
That'll be just 2 pi times that, right?
Pi, yeah.
So this is coming out negative. What's that telling me? Along that full circle, at least I know most of the vectors were what? In that vector field, we're going against my path. Cool. Hey, last problem. You know how to parameterize a circle, right? How do you parameterize a line? Okay, that's the last problem. You go, what do you mean? They gave us one before. What do lines look like? Not cosines and sines. What do lines look like? 2t plus 1 or something like what? t plus 2, right? This is what lines look like. So we're going back to something back from chapter 12, everyone. You remember how to make parametric representation of lines. This is the last problem. And when can you use find the work done by the force field to move a particle? You got to go along the line segment. Okay. And we got to move a particle along the line segment. From, so this is number 14, 0, 0, 2 to, what's the other point? 8, 2, 0. Okay. What's the vector field? The vector field is, nothing crazy, oh, it's three-dimensional though. The vector field is YZX. Okay. So last problem. Find the work done by this vector field here, the force field, to move some particle along the line segment from 0, 0, 2 to 8, 2, 0. That's going to be your curve path, but it's a line. So the challenge is, how do we make a parametric representation of a line? You remember how to do this? It's not bad. I mean, how do we parameterize a line? So I'll just call it what? RT? So here comes my line. This is that line, the path. This is the curve. My line is, what's the point? I need one of the points.
0, 0,
It's important to use the one it started from. Where did it start from?
0, 0, 2.
So I'll put 0, 0, 2. This is how we parameterize the line. Now we're going back to chapter 12. Plus, plus, plus. a T and a T and another T. What goes in front of these T's? The parallel vector. The parallel vector will be in front of those T's. How do I get a parallel vector from this? Tip minus tail, you got a great memory. Very good. So when you help me get these numbers, this is going to be the parallel vector that runs in the same direction as that line right there. What's 8 minus 0?
8.
I'm going to use that. 2 minus 0? 2. These are the numbers I'm going to put in front of the T's. And be careful here. What's 0 minus 2?
-2.
There you go. So there's my parallel vector 2 line that I'm going to put in front of those T's. And we just parameterize the line. Let me see. 8, and this is 2, and this is -2. These underlines out of the way. There we go. Got it. So those are 2 key things we need to know how to do. How do I parameterize a circle? Cosine and sine. How do I parameterize a line? Get the vector, the parallel vector by tip minus tail, and you got it. So there's only one big dilemma left. We'll have no problem substituting this stuff. Does anybody know what the limits are going to be? It's surely not going to be from 0 to 8. Because those are x's. These are y's. These are z's. We're getting what? I'm going to put the limits there. Do I have enough room? What goes here? This will be f. Oh no, that's just y, z, x. And then I'll put a dot, and what goes here?
So
R
that's
prime of t. Well, let's start out, and then we'll come back to this at the end. Because it's going to be real easy. What's f composed of r of t? So I got to put the y. Where's the y component?
2t.
Excellent. You go look at the curve you just made, which was a line, r of t, and you substitute this there, 2t. What gets substituted there? 2 minus 2t. Do I have enough room? 2 minus 2t. Yeah, I got enough room. And what goes right there?
8t.
Just the 8t. Okay. Good, I do have enough room. So far, so good? 2t, 2 minus 2t, 8t. F composed of r of t. Now, not r of t, but r prime of t. What's r prime of t?
8, 2,
8,
2,
2, and
1.
is that negative 2?
-1. -2, yeah.
All right, 8, 2, negative 2.
Mhm.
We'll do this. So the big question, what's the limits of integration? What t value you made it go from here to here? It's really simple. You know what it is? 0 to 1. Is it always going to be that? Yes. You know why? If you always do tip minus tail, you can check it. Every time you do tip minus tail, you're saying this is going on at what? That's t equal to 0. Because we did tip minus tail, this will be the t equal to the 1. 1.
Ah.
Isn't that cool? You can check it. And when you want to, let's just make sure we did this right. Plug a 1 into your path. We should get that point, do you? If I plug in a 1, I plug in a 1, I plug in a 1. Do I get that point?
Yeah.
So this will happen every time because you're doing tip minus tail. There's 2 points. Isn't that cool? So circles, 0 to 2 pi for a full loop. You're doing one along a path that's a line segment, and they give you 2 points. You figure you parameterize the line, but you're going to be going from 0 to 1. Cool. Hey, what is this got product? We'll just wrap it up. What's 2t times 8?
16t.
16t. Plus
4 minus 4t.
4 minus 4t.
Minus 16t.
And then minus the 16t. dt. Any like terms in there?
T and
Oh, cool. Did this really work out just nicely for our last problem? Did these go away? Yes, I love it. Thank you. 4 minus 4t. All right, what's that integral? What's 4t minus 2t squared? What's the work done along that path? 2. So it appears now, everyone, along that path, most of the vectors in that vector field were going at least in the same direction as the path. Cool. So and that's it. That's 16-2. Super job. Great, great.